All right, 6.8 graphing. And again, the graphing in Delta Math is not quite as intense as we would do without it, but there's some discovery problems and some transformations. But we get back to the H and K stuff that we talked about earlier in the year, just this time dealing with radicals and square roots. So we're going to look at a couple. And again, just looking through this, okay, to look at the forms that we have y equals a times the square root of x minus h. That's all underneath the square root, and then my k is outside. So remember what a does to the graph. A is going to make the graph flip about the x-axis if negative. Okay. If a is greater than 1, okay, greater than 1, then it's going to get smaller, or it's going to thin out. So what we call it a vertical um, stretch. Okay, so as we do that, the graph's going to get thinner. I don't want to call it thinner. We'll just call it smaller. Okay. And then if a is less than 1, which is a fraction, okay, it's going to get larger. Okay, as we go through and graph this. And then h is my horizontal shift, and that's going to be the opposite. So again, if it's a plus, then it goes to the left. If it's a minus, it goes to the right. And then k is my vertical shift. Okay, and that's the same. So if it's a plus out here, it's going to go up. If it's a minus, it's going to go down. So, and again, it's the same thing as we go through. I want to look at this because I might have these backwards. Actually, I think I do. It's inverse. When you put a 2 in front, it actually gets larger, and you put a fourth in front, it actually gets smaller with these ones. So let's fix that right now. Erase your notes. Sorry. But if you put a 2 in front, it actually vertically stretches the graph. It makes it larger because, again, these are inverses of something being squared. And because it's the inverse, it does the opposite of it. So, and we'll look at a few examples. But in doing that, and then if this x is negative, and I haven't talked about this a whole lot, but if this x is negative underneath, it actually flips it about the y-axis. So what does the parent function look like? A normal or a rational radical graph just looks like this. And then if you have like y equals the square root of x plus 2, that would just shift it to the left 2. Same exact picture. If you put a 3 in front of it, that's where, like I said, it's going to look a lot bigger. It like multiplies it by 3 and expands it by a total of 3. So it doesn't actually make it skinnier, it makes it bigger when it comes to these graphs. So let's take a look at some Delta Math problems. Oh, I want to talk about this. If I give you an index, so if I put an a in front and then have a cube of x plus h, x minus h plus k, same exact thing, but that parent function kind of looks like the parent function of a cubic graph looks like this. So it's got this going, and then it goes. So it's almost like the cubed graph, but it's flipped on its side, and that's how it would look shifted, or the parent function. Then when we talk about the the h and the k moving, we always talk about this point moving left to right. So I want to look at some problems in Delta Math, just different ways that you're going to be asked to do this. And I'm going to make sure that they're only square roots. So we had some problems like this earlier. No, hold on. Let's see if this is it. No. And I'm making sure that they're only radicals for us when we do these. So here we go. Okay, so how would we get from this graph to this? Well, this is a square root graph. Okay, So this is a square root graph, and it's positive because it doesn't flip about the x-axis. So this stays put, and then it's going to shift to the right 2 units. So how do I get it to go to the right 2? I'm going to put a -2. -2 would make it go to the right, and then it goes down 1. That's my k, and my k would go down 1. So look, opposite is my h, k is my the same. So you just submit it. When you're done with it, don't forget, yeah. So, and it'll move it on its own. So you can submit it as you go through that. And submit it, and when they match up, you say yes. So again, that's just messing with the H and the K and a little bit of A. Go back and look at some other problems that you're going to have to do. Same thing with transformations discovery. Those are just going to be cubic. So now we have some problems that no, you won't have any quadratics. There we go. Okay, so now we got to put in the equation. Well, what does it do? It goes to the left 3. So inside going to the left would be a plus. So it's going to be either these two, and then it goes down 5. So it would be this problem right here. Okay, so again, just looking at H and K for some of those. And then the last couple that we're going to do, you're actually going to have to translate them. You're going to move them. So nope, we don't have any exponentials. No exponentials. Here we go. Okay, so what does this graph do to? So here's the cubic graph. Here's the parent function. -3 means it would go to the right 3. So you just click on it and you drag it over 3 units. That's it. Submit it. That was a -3, right? Yeah. Okay, so it's just looking at your H and your K's as you go through these problems. Again, what does the +3 mean there? You would move it to the left 3. I don't think there's any more that have both of them. Oh, there we go. I wanted that one back. I wanted to show a K. Come in, yeah. There we go. Okay, so again, what does this +2 do? It moves everything up 2 units. You click on it, you drag it up 2. It'll put it right there. Yeah, submit your answer. So that's just moving H and K. So I think this should be a pretty simple section. It's dealing a lot with H and K. Don't forget that if the X inside or underneath the radical, it's going to flip it about the Y axis. So it kind of shifts it over this axis here. But I think this should be a good last section for chapter 6. That'll kind of lead us into break here as we do a quiz over the 6.4 through 6.8, and then get caught up on all of our work. Right. Hope you guys are all doing well. Have a good one.